Hello, hello, hello. How are you guys doing? I hope all of you are doing good. Today I've come up with a problem daily temperatures which will help us to understand the monotonic stack. So this problem daily temperatures is from lead code question number 739. The problem states that given an array of integers, temperatures represents the daily temperatures, return an array answer. Okay, so that means we have an array of integer temperatures which represents daily temperatures. That means each value of the temperatures array represents a temperature, daily temperature on that particular day, on that particular index. Okay, so indexes here represent day, and the value on that index represent the temperature on that day. Okay, so return an array answer such that answer I is the number of days you have to wait after ith day to get a warmer temperature. That means we have to return our answer in an array form in which every index will contain the difference of the days we have to wait to get the warmer temperature after that particular index. Okay, let's take this example. Let's say for 73, I have to get the next greater element, that is next greater warmer temperature. For 73, we have 74, which is just a day after it. That means there is only 1 day difference. For 74, we have 75. That means 1 day difference. For 75, we have next greater is 76. So 75 is on index 2, day 2, and 76 is on index 6. That means day 6. So the difference we have to wait is 4. 1, 2, 3, 4. We have to wait for 4 days to get next warmer temperature or next greater element. Okay, so for all of the indexes we have to find next greater one. Okay, so let's come with a brute force solution first. The brute force would be for each index, I'll look into the array after it and find the closest greater element and update my result array. Okay, for 73, I'll go from 74 and check for the next greater one. So 74 is 74 greater than 73? Yes. So what is the difference here? 1. So the answer 1. Okay, for 74, I'll start from 75. 75 is greater from 74? Yes. The answer is 1. For 75, I'll start from 71. 71 is greater from 75? No. 69 greater? No. 72? No. 76? Yes. So I'll update the difference of current and the uh, current index which I'm checking for, and the current index which I'm at in the inner loop. Okay. So 6 minus 2, which is 4. For 71, we have 72. Similarly, for 69, we have 72. 70, for 72, we have 76. So this is the output array. Okay, so the brute force code will look like this. The brute force will look like this. Okay, so here I am initializing a answer array with zeros, and for each index in temperatures array, I'm finding the next greater one using a loop. Okay, so the time complexity of this solution would be O of n square. But we have these constraints attached, and the O(n) square time complexity will not work for this. So we have to come with a better approach, which would be the monotonic stack. Okay, so what is monotonic stack? The monotonic stack is of two types: monotonically increasing stack and decreasing stack. Monotonically increasing stack is um, first of all, what is monotonic stack? So it is nothing special than a normal stack, but it stores the values in a sorted order. Okay, either in a ascending order or a descending order, and it does not store all the elements. It does not store all the elements. Okay, so for increasing stack, the monotonic increasing stack is sorted from bottom to top in ascending order, and the monotonic decreasing stack is sorted from bottom to top in decreasing order. Okay, so this was a theory behind monotonic stack. And how are we gonna use it? I'll show you using a dry run. Okay, so I hope you understand the logic of monotonic stack and how are we gonna achieve this is this code which I'll show you using a dry run. Okay, so we have to get the next greater element. Whenever you have to get next greater or next smaller element, you'll go toward monotonic stack. Okay, so in this case, as we have to get the next greater element, we'll iterate from the right side. Why right side? Because because if we come to any specific index, let's say for index 4, we have 69 and the answer should be next greater element. That means the answer is lying within this part of the array. And if I iterate from the left side, how can I be how can I get the answer from the left portion? That's why we are iterating from the back of the array. Okay, so first of all, when we come to index 7, which is the last index, we have the value 73 here. Okay, for 73, we'll check if our stack is empty or not. If it is currently empty, we'll leave it. Okay, we'll leave it, and if it is not, then we'll do something which I'll show you. For 73, it is empty. Okay, so the result array will stay untouched, and we'll also put 73 into the stack. Okay, you only have to put the index of the element in the stack, not the actual element, because we can get the element using the array indexing, using that index we have stored. Also, because we have to get the differences of the days, I'm storing the index in the stack. So I'll push here index 7. And just to show you for visualization purpose, I'm also writing 73 here, the value. Okay, I'll push 7 comma 73 into the stack. Again, you don't have to actually put the value, you'll only store the index. For visualization purpose, I am pushing the value also here. Okay, then we come to index 6. For index 6, we have 76. Okay, so for index 6, we have 76 here, the value. Okay, again for 76, we will check that if the top element of the stack is greater or smaller than the current element. That is, if the element on index 7, which is the top of the stack, is greater or smaller than the current index element on current index, which is 76. Okay, so 73 is smaller than 76. So while the top is smaller than the current value, we'll pop it out. Okay, we'll pop it out because we don't need smaller ones. We need the greater element on the right side. Okay, so will it not, uh, will it be beneficiary? Will the value be not useful for future elements? The answer to this is no. Why? Because in future, either I'll get a smaller value than current value, that is 76, I'll get a smaller value or a higher value. If I get a smaller value, then the answer to it would be 76. The next greater element is 76. And if it is higher than the value, then I don't have to worry about smaller values. Okay, I have to find next higher element. So if the 76 is smaller than any value, then all the values smaller than 76 are also smaller than that value. Okay, so we are popping them out. For 73, we'll pop this out and update the result for 76. Because the stack is empty, the result array will remain unchanged. And we'll push this 6,76 into the stack. Then we come to index 5. Index 5, which is 72. Okay, again for 72 we check, is 76 lesser than 72? No. That means we have a next greater element. We find our next greater element. We found it. So the next greater element to 72 is 76. So we'll update the result array with the difference of the indexes. See, 6 minus 5 is 1. That means we have to wait for 1 day on 5 to get next warmer element, warmer temperature. So I'll update the result array here with 1. which is 6 minus 5 only, nothing else. Okay, then we push this into the stack. After that we come to index 4, which is 69. Okay, for 69 we check, is 72 less than 69? No. Then we'll only update the result array with the difference, which is 5 minus 4, again 1. Okay, will not pop it out because 72 is greater than 69. So that's why I'm pushing it into the stack again. Then we come to index 3, which is 71. For 71, is the top element, which is 69, less than 71? Yes. So we'll pop it out. After popping it out, what is the top element? 72. What's the index? 5. So the difference would be 5 minus 3. 5 minus 3, that is 2. That's why that means we have to wait for 2 days after 71 to get next greater element. Okay. That's why I updated the result array with 2. And we'll push this into the stack. After this, we come to index 2, which is 75. Now see, for 75, is 71 greater than 75? No, then pop it out. 72 less than 75? Yes, then pop it out. See, I used both of the both of like both of the sentences. Is it greater than? No, then pop it out. Is it less than? Yes, then pop it out. Okay, so don't be confused from it. Okay, is 76 greater than 75? Yes. Then update the difference on that index. What is, which is 6 and 2. 6 minus 2 is 4. So we'll update 4 here and push this into the stack. After pushing it into the stack, we come to index 1, which is 74. Again, we check for 74. The top element is 75. So which is greater than 74. So we'll update the result array as it is. 2 minus 1 is 1. So we put 1 here and push this into the stack. Okay, then again we come to index 0. The value is 73. For 73, is top element less than? No. So don't pop it out. Don't pop it out and update the difference, which is 1 minus 0, which is 1 only. Okay, and push this into the stack. So after iterating the complete array, the result array looks like this. Okay, which is exactly what my lead code answer output wanted. 11421100. Okay, so this is the result array, and the code is this. You can check the code itself. Here we are initializing a result array with n number of zeros. That means n length of array with zeros initialized, and we are initializing a stack here. And then we are iterating from the back side. That means index n minus 1 and taking steps minus 1. Now for each element, while stack is not empty and the element on the top of that stack is less than or equal to the current value, we'll pop it out. And after we are done popping, if the stack is not empty, that means there remains an element in remains some element in stack. That means we have a greater element. So we'll update the result array with the difference between index and the index of top of stack. Okay, then after that we'll push a current element or current index into the stack. After we complete iterating the whole array, we have the results array as we want. Okay, so this was the approach, and this next greater element is a very common approach. These are some similar problems which use exactly same approach, next greater. And yes, if like for some problems you have to find previous greater, then for previous greater one you'll iterate from start. Okay, you'll iterate from left. For if you have to find previous greater one, then you'll start from 0. If you have to find next greater one, then you'll start from right side, n minus 1. Okay, so these are some similar problems which are on exact same template. I hope you understand the monotonic stack concept and this problem. You can again see the code. That's it. Thank you for watching.